I have seen some crazy comments in my day. None more crazy than this one. Okay, where the fuck's the comment? Ah, there it is. No, hold on. There it is. They are as accurate as they need to be. They will have an error of 1 second in up to 100 million years. In a satellite, they are completely useless, which is why we beam time to satellites. I need to edit that. There's no supposed to be a W in the to satellite. Who cares? So, let's take a look at this. Atomic clocks losing 1 second in every 100 million years. Boop. Actually, due to combined effects with relativity, atomic clock's GPS satellite will gain 38 microseconds per day compared to a clock on the Earth's surface. This is particular about where on the Earth's surface. It's different depending where you are. Which does not lose time. Actually, this is a fucking hoax. Set atomic clocks on the Earth's surface. You realize the Earth is slowing down. In the course of time, the Earth has continued to slow down. So this is incorrect. Because if Earth continues to slow down, eventually it will become so slow, gravity will not be the same, and the effects that are affecting the atomic clock will be completely useless because you will fly off the planet. But who cares about that? On the Earth's surface, it's a lot slower, about 7 seconds a day. Right? Regardless of how this all works out to be 45, 7, 38 microseconds gained per day, or however it works out, the point is that the atomic clocks are not perfect. They are definitely inaccurate. Again, the guy says they will only lose it over 100 million years. Nowhere does this say anything about 100 million years. Atomic clocks on satellites deliberately set to run at a slightly slower frequency instead of the regular frequency before launch, so that once in orbit that they tick at the correct rate relative to ground clocks. This is not true. We literally have to beam the time up to the satellite. There is no perfect satellite atomic clock system. No. Yeah, cesium atom 133 to be exact, to 9 billion something when expressed with a unit of hertz is equal to something. Time accuracy atomic clock matters because even in a timing error of 1 nanosecond or 10 to the minus 9 power corresponds to positional error roughly 30 centimeters when multiplied by the speed of light. I don't know why you would multiply anything by the speed of light regarding the way that it works, but when you consider the resolution of a nanosecond and it being different than regular time for every bounce in an atomic clock, the number of bounces per instant means that that number will accumulate over time. And yeah, the atomic clocks are faulty. They're not great. They are, yeah. Today's cesium clocks are something with ions cooled to near absolute zero. For example, the NES hates something in the clock names something without its relative uncertainty of around 10 to the minus 16. Again, that's, I mean, 10 to the minus 16 is pretty, like, extremely tiny deviation, which only means that it takes another, I don't know, 1,000 intervals. What is the difference? It's a million intervals in order to receive the same amount of time discrepancy. I mean, that's nice. I'm glad they made some progress, but still, I've been looking forward to the idea of atomic clocks being accurate, but the problem is that I guess when last I checked, the ultra precise timepiece thing still has things like, I don't know, like in the 70s they mentioned time dilation stuff, which I am still disproving to this day. Or I still have yet to fully realize the disproving of that. But no, it's something that is inherently, I don't know. Terahertz are much more stable than cesium clocks at only 9.19 hertz. Yeah, strontium. Yeah, those are extremely accurate, or they must be, because they are so fast, so able to understand things in the terahertz range. Like, the only way they can lose a deviation is if they lose like a certain large portion, certain things interacting with it, like, I don't know, cosmic rays, is also taken care of with how they shield it, most likely. But I mean, there's neutrinos, they go through everything. You can still have not exactly 100% infallible systems, but I mean, it's a lot better. But also, there's ways of compensating for all of those different the noise and everything. If you can sense the noise, like you have a sensor, then you would be able to compensate for whatever noise might be introduced into the clock. So you can do all these things and have accuracy. But still, nowhere in any of this do I see something about 100 million years. They literally pulled that one out of thin air. I mean, maybe it has something to do with the 10 to the 13th or something with these numbers that are big. But again, um, no. Still limited to one part in one to one part in one and 10 to the 16 for you to laser a host variety of experimental optical clocks is hard. There's a different elements, the different experimental set. Helps you want to compare the optical clocks against each other to see whether or not they agree. The other thing is, if you have different types of sensors, different types of optical clocks, you can compare them all and have time that then references each other, and then they can compensate each other to then know, like, whatever happens to this clock, we can also compensate and know what's happening in the other clock, and vice versa, or something, and stabilize. Also reference to all things happening within the thing. Do not. Hello? Um, the number of leap seconds is changed to that the solar noon at the prime meridian does not deviate for 0.9 seconds. What? Data is not distributed everyday timekeeping. Instead, it is integral to number of leap seconds added or subtracted to correct the Earth's rotation. Yeah, because the Earth's rotation, as I said, is slowing. So you have, like, it's slowing over a certain amount of time. So a small amount deviation per. So, like, if you still worked with a sundial, for example, you would still see, obviously, 24-hour clock, but it would not be accurate to say 24 hours has actually passed when you look at the actual amount of seconds that are supposed to be in a day, and then the next year it had, or given a certain amount of years, eventually the days don't last that many seconds, depending on not just when you are in the season, which is how close you are to the sun versus away, but also from one decade to the next. There is a difference. It is slowing. So it's a whole thing. And whatever. I'm still not seeing anything about 100 million years. Blah. There's no results for this. Yeah, to the border, something. Yeah, there's still no actual. Okay, hold on. 300 million years. Interesting. I mean, again, that's for a clock on the ground, is what I assume. But in a satellite, you have constant slowing down of the satellite. 100 million years. Season found on top of clocks. Even when you have something like this says 300 million years and the other one says 100 million years, you realize that there has to be some amount of unsurety about all of this because they can't both be right. One is 3 times as much as the other. That can be very not helpful for finding out reality if you can't be sure of what is all happening. But I mean, eh, the hell is all this? The uncertainty of 1 second in 300 million years. Oh, that's different. Atomic clocks these differences with uncertainty of, yeah. I don't think that's the same number in relative to the situation. This one is the actual thing to reference 100 million years. Maybe there's actually something here. Atomic clock dial neither gains nor loses 1 second in 100 million years. Yeah, sure. I mean, uncertainty of 5 to 10 to the minus 15. Cesium clock, national prime. Right. Is this the thing that they have in these atomic? They have this device that's throughout all of sci-fi, and what if it's just a clock, and it's actually that thing that people have everywhere, and it's just the timepiece, but no one ever says it's a timepiece because it has like these 3 laser beams that change alternating, and they're like they could be atomic clocks for all we know, but we never see these. I've never seen this device. It's fascinating. It reminds me very much of that science fiction video. It was in Star Trek. It was in all sorts of different other science fiction. This one prop was just used everywhere. It doesn't look like this exactly. It looks like something else, but it very much reminds me of that prop. Anywho, that's about it. So, I mean, he's not wrong about it being accurate on the ground, and I'm not wrong about it being completely useless in satellites. That's the way it works. That's why we beam the time to the satellite.